We're going to look at this equation and see if it obeys the law of conservation of mass. The first thing that we're going to do is we are going to write down all of the elements that are present on our reactant side, and we're going to write them like underneath our yield sign right here. So our reactant side is the left side of the equation, and we're going to write the elements that appear on our reactant side. C and H. So that means this one right here is an organic compound because it has carbon and hydrogen. And then we've got our oxygen right here. Now notice we can't make new elements in a chemical change. So so we got the H, the O, and the C. So that means we did not make any new elements. We did make some new compounds. That's allowed, but we're not allowed to make new elements in a chemical reaction. Okay, we have an understood coefficient of 1 in front of our C3H8. We're going to take that understood 1 and we're going to distribute it to those subscripts. So we have 3 C's, 1 times 3. We have 8 H's, 1 times 8. And then with our oxygen, we're going to take that coefficient, the big number of 5, and we're going to multiply it by 2. So we have 10 oxygens. I'm going to total up this side, so that's 18 and 21. I have 21 atoms. So in order, first of all, for this to be balanced and obey the law of conservation of mass, we're going to have 21 atoms over here as well. Then we're also going to have to make sure that we have atoms, the same number of atoms of each element. But first, we're going to just total up what we got. So we have a coefficient in front of our water, H2O. We're going to take that coefficient and we're going to distribute it to the H and the O. Now, the O doesn't have a subscript, so we have an understood subscript of 1 right there. So our H is 4 times 2. It's looking good so far. We have 8 H's, and our O is 4 times 1. So we got 4 there. Now we got some more O's over here that we're going to be able to add to that 4 to see, and we'll see if we get there. Okay, so the same thing with our CO2, our carbon dioxide. There is an understood 1 behind the C. So we take our 3 times 1 and our 3 times 2. And that's going to give us our totals for our carbon. Carbon is going to be 3 times 1. And oxygen is going to be 3 times 2, so 6. So I need to add it to my 4 from over here. So you can see that I also have 21 atoms on this side. This is a balanced equation, and it does obey the law of conservation of mass. Here is our second equation. We're going to do the same thing that we did previously. We got our reactants, we have our products, and then we are going to put our elements that make up the reactant side. We have P for phosphorus, O for oxygen, H for hydrogen. I'm not going to list that second oxygen because we're going to total it all up because it's the same element. Okay, so on our P4O10, there's an understood 1 in front of the P4O10 because there's no coefficient there. So I'm going to take my 1 and multiply it by 4 and distribute it also to the 10. So that means I've got 4 phosphorus, 10 oxygen. On my water, my H2O, I'm going to have to take my 3 and distribute it to not only the H but also the O. And we have an understood 1 on the O, the oxygen. So 3 times 2 for the hydrogen is going to be 6. And 3 times 1 on the oxygen is going to be 3. All right, so we're going to add these up. We've got 13 oxygen, 4 phosphorus, 6 hydrogen. You do kind of have to be careful sometimes. Obviously you don't have 100 oxygens there. You have oxygen, you have 10 of them. Okay, let's look at our product side. We have to distribute the 4 to this entire compound. So let's do that. And phosphorus has an understood 1. So we take 4 times 3, and that gives us, on the h's, that'll give us 12 h's. So we can already tell does not obey the law of conservation of mass because you don't have the same number of h's. But we'll keep going. 4 times 1 on the phosphorus, so I do have 4 phosphorus. And then 4 times 4 on the oxygen, so I have 16 oxygen. So my total number of atoms over here is going to be that 17 and 6 is 23. And so that's 20 and 12 is 32. So this one is not going to obey the law of conservation of mass because I do not have the same number of atoms on each side, on each reactants and product side, nor do I even have the same number of oxygen or hydrogen. So this does not obey the law of conservation of mass. This is the last equation we're going to be practicing in this tutorial. So we've got our reactant side, product side. We're going to record. We only have 2 elements for this. We've got Fe, which is iron, O, which is oxygen, and we have an understood 1 on our iron. So we're going to take 4 and multiply it by 1. So on our reactant side, we have 4 irons. We're going to take our 3 and multiply it by 2. So we have 2 times 3. So we have 6 oxygens. Here, we're going to take on our product side, we're going to take our 2 and multiply it by 2. And then we're also going to take our 2 and multiply it by 3. So basically what we have here that's rust. That is actually the formula for rust, combining iron and oxygen. So 2 times 2 is 4. 2 times 3 is 6. We have 10 atoms on each side, and we have the same number of each element, same number of atoms of each element. So this equation does obey the law of conservation of mass. You'll see a link for an assessment that you need to go take when you have completed this, when you've completed this tutorial. Go take your assessment. Good luck. I know you're going to do great.